Okay, another kind of transformation is called a translation. And just like you translate a language from one to another, we can translate figures on a coordinate system. The shortcut that we're going to talk about a translation is we're going to talk about it as a slide. We are just going to pick the figure up and slide it from one area to another. When we talk about sliding a figure, we have to know our directions. Are we going up, down, right, left? And what's going to happen is anything positive is meaning we're going to go up or right, and anything negative is we are going to go down or left. Now, up and down are going to be how our y's change. Right or left is how our x's change. And the way we write the rule for this, I come down here, the way we write the rules, we talk about our original, t of x, is going to become t prime by whatever we add or subtract from our x and whatever we add or subtract from our y. So h and k will become numbers that tell you how to translate, how to slide the picture from its pre-image to its image. Just in general, a couple of cool things about translations is if I connect B to B prime, A to A prime, and C to C prime, all of these distances are equal and all of these lines are parallel. And that's a very cool property of translations. So let's look at an example. Translate this figure 5 units right and 3 units down. Write the rule and the coordinates. So our rule is t of x, y, is going to become t prime of 5 units right, that's our x, y. Going right, we're going to add 5. 3 units down, we are going to subtract 3 from every y. Now we could go over to this picture and we could say, well, that means P has to go 5 right, 1, 2, 3, 4, 5, and down 3, 1, 2, 3. P prime goes right there. And you could take X and you could go 1, 2, 3, 4, 5, down 1, 2, 3. And you could put X prime here. But that's a bit petsy and a little error prone. So instead, what we want to do is we want to talk about P being at negative 7, 7. And when we run it through our translation machine, P prime is negative 7 plus 5 and 7 minus 3, which means P prime is at negative 2, 4. And then you can go ahead and plot that. And then we can go ahead and we can say that X is at negative 3, 7. So that means that X prime is at negative 3 plus 5 and 7 minus 3. Trick is not to combine these. Remember, these are ordered pairs. And so X prime is 2, 4, which I have both of those graphed. So then L is at negative 6, 4, which means that L prime will be at negative 6 plus 5 and 4 minus 3. So L prime will be at negative 1, 1, negative 1, 1. And our last point is B, and B is at negative 2, 4. So B prime is at, now if you can do this in your head, it's fine. I showed the long work. Negative 2 minus 5, or plus 5 is going to be 3, and 4 minus 3 is 1. You can jump straight to that point, 3, 1, if you want. Otherwise, show your work. So here is our figure. Now, if we think about our properties of ABCDO, what happens here? Our angle measure is preserved. Our betweenness is preserved, our collinearity is preserved, and pretty sure our distance is preserved. And we could go through and check that. But these are all preserved. I didn't change the size of my figure, I just picked it up and slid it over 5, down 3. I didn't make it larger or smaller. Now, if I look at the orientation, if I talk about P, X, B, L being congruent, because translations do make congruent figures, its corresponding figure would be P prime, X prime, B prime, L prime. If I look at the orientation on the first figure, I made the orientation clockwise, and when I check, my orientation is still clockwise, and so orientation is also preserved in a translation, which is different than in the reflections. A couple more examples. Translate the figure by this rule. So here we're given the rule. I'm going to take every x, I'm going to subtract 3, and every y and add 2, and that will give me my new point. All right, so the easiest thing to do here is to label your coordinates and make a list. And so u is at -2, 0. Y is at -3, -4. P is at -5, -5. And W is at -6, -2. I always make a list because it gets too squishy on the graph to try to be listing everything. So then we run each of these points through our rule to get our new points. -2 minus 3 is -5. 0 plus 2 is 2. Y prime, -3 minus 3 is -6. -4 plus 2 is -2. P prime, -5 minus 3 is going to be -8. -5 plus 2 is -3. And our last order pair is W prime. -6 minus 3 is -9. -2 plus 2 is 0. So now I know where my points are. I'm going to go ahead and graph them. So U is at -5, +2. There's U prime. -6, -2 is Y prime. And it's okay if our points, new and old, overlap each other. -8, -3 is P prime. Let's move my notation here. Y prime, -8, -3 is P prime, and W prime is -9, 0. And when you connect those, you can see that my picture has retained its shape. These distances would be the same where things get moved, and the orientation is also maintained. Our last example is going to ask us about finding the rule. So this is a matter of trying to figure out how I move from the original, from the pre-image, to the image. So if I take H, I'm going to go, my x's will go over to here, and then my y's were obviously changed from here to here. So my x's, I went 1, 2, 3, 4, 5 right, and my y's, I went 1, 2, 3 up. Now it's a good idea to test this with one of the other points just to see if you're right. If I go 1, 2, 3, 4, 5, up, 1, 2, 3, I get to where I need to go. And so my rule is take your old, and it becomes all x's I add 5 to go right 5, all y's I add 3 to shift it up 3. And that's all there is to writing a rule. And just to recap, when it comes to our qualities of A, B, C, D, O for translation, all are preserved for